Hello and welcome to AnyLogic Road Traffic Library. My name is Arash Mahdavi and I'll be your host today. Let's begin by some housekeeping items. Recommendation for your audio setting is to use your speakers or headset in listen only mode. If you choose to dial in through a landline, expect some delay. Submit your questions through the Q&A pod. I will address all the questions at the end of the webinar. You may enter the full screen mode during the webinar by clicking on this, by clicking on the icon on top of this screen. So you can click on that icon and see the webinar in a full screen mode. For efficiency purposes, I've pre-recorded the model building process. Don't worry, all the steps are included. I recommend watching the entire webinar and don't worry about following along. You will receive the recorded webinar, Q&A session, and also the model source code in a few days. Your feedback is very important to us. After the webinar, I will share a link to a short survey to you. Please share your thoughts with us. It's very helpful for future webinars. So these are some of the objectives of the current webinar. We are going to create the road network based on a satellite image that we bring into the model. We will build the traffic flow logic, traffic light setup, and we will optimize the traffic lights. We also add parking lots and bus routes to our model. We also show you how you can integrate pedestrian library with road traffic library in AnyLogic. Before I start, I want to show you an overview of the model and how it looks like. Let me share my screen so you can see the model itself. So this is the model that we are going to build. By the way, this intersection is near Civic Opera building in downtown Chicago. This is where the AnyLogic North America office is located. And we are going to build these road network. We will build all the logic associated with the movement of the cars. We will show you how to add statistics about the car movements in the network. And at the end, I will show you how you can incorporate and add a pedestrian library and pedestrian movement to and integrate it with the traffic library, as you can see in this part of the flowchart. Okay, so let's go back and start watching the model building process. At the end of this video, I will come back and answer your questions. Let's start by creating the road network. First, we need to add a new model. We give it a name and keep the default model time unit, which is seconds. Next step is to add a satellite image by bringing it from the presentation palette. I check the lock checkbox to make the image unselectable by left click. We also have to scale this model. According to the image scale, ruler length should correspond to 120 feet. Okay, let's disable the grid to draw the roads freely. I start drawing the roads by double-clicking on the road markup element. This part of the road network has 4 forward and 4 backward lanes with a 10-meter wide median strip. I changed the median strip color to grass texture. Next, I start drawing this part of the network and connecting it to the median of the previous road. To draw the other part, I should put the road start point close enough to see its color change to cyan. Both of these sections are one way and have 4 lanes. We can adjust the location by mouse or keyboard arrows. We can hide a space markup element to see the image underneath. This will help us to adjust our markup elements. Now I draw and adjust the other segments of the road network, which are similar to the last step. By clicking twice on any segment of the network, you can select the entire network. I changed the road color of the entire network to tarmac texture. As you can see, AnyLogic draws some lane connectors by default. I want to disable some of them to customize the traffic directions. To do so, I have to select the intersection first. The selected intersection would highlight the lane handles. As you can see, I can disable or enable its lane connectors by clicking on them. I do the same for the second intersection. Let's add the traffic flows logic. This part of flowchart relates to the cars that start from the upper left segment of the network and will go to the upper right segment. I start by adding a car source block, then a car move to, and finally a car dispose. This part of flowchart relates to the cars that start from the bottom right segment of the network. These cars have 3 options: continuing straight, turning right, or turning left. Road Traffic Library is interoperable with Process Modeling Library and other standard libraries of AnyLogic. As you can see, I used Select Output 5 from Process Modeling Library here. This part of flowchart relates to the cars that start from the bottom segment of middle road. These cars have two options, continuing straight to upper part of the middle road or turning left. The last part of flowchart relates to the cars that start from the top segment of middle road and go to the bottom segment of it. Let's make some minor adjustments and then move to associating the flowchart blocks with space markups representing different segments of the road network. First, this car source should be associated with the left segment of the upper road. This car move to should be associated with the right segment of the upper road. The cars that start in the right segment of the bottom road have three options: turning right, turning left, or continuing straight ahead. But first, let's adjust the probabilities of each car choosing any of these three options. Now I associate the flowchart blocks with the space markups. The cars that are turning right will go to the upper segment of middle road, but in the backward lane. Therefore, I have to check the end of backward lane check mark. These cars that start from the bottom segment of middle road will start in a backward lane. They have two options: continuing straight, which means going to the end of backward lane, or turning left. Finally, the cars that start from the top segment of middle road will go to the bottom segment of it. Let's save the model and run it. As you can see, I received the car failed to change lane error message. This is due to the fact that this car started from a lane on the right side of this road and did not have enough space and time to reach the left lane. We can increase the length of this road segment or put these cars on a specific lane from the beginning. However, I'm going to use the outway not found port. Basically, I'm telling the cars that want to turn left but are not able to reach the left lane on time to continue straight ahead. Let's run the model and see the result of this modification. Okay, let's change the portion of the cars that should turn left in the lower intersection to 30%. I also want to let the cars that start on the bottom right segment of network to continue straight ahead in case they cannot change lane on time to turn. Let's take a look at bottom intersection during the runtime. As you can see, cars that are turning left do not stop for the incoming traffic. To add a yield sign, I select the stop line and check the yield checkbox. Now, if I run the model again, we can see that the cars that are coming from the bottom segment will let the others to proceed if they reach the intersection at the same time. Okay, let's set up the traffic lights. I will drag and drop a traffic light block to the model. The mode of the traffic light is intersection stop lines. I select the upper intersection. Let's add 2 yellow phases and change their duration to 5. I also changed the other 2 phases duration to 30 seconds. After selecting a traffic light phase, I can change the color of each stop line by clicking on it. Now I'm adding the second traffic light. Its mode is intersections lane connectors. By clicking on each lane connector, we can set its color during each phase. Now that everything is set, I can run the model to see how the traffic lights will affect the traffic. In this intersection, you can observe the effect of the yield sign on the cars who want to turn left. Okay, it looks like the cars behave as expected. Let's optimize the traffic lights. First, we need to add a custom car type that knows the time it entered the model. We can add a custom car type from the Road Traffic Library palette or from the Create a Custom Type link in the car source properties. We create the agent type from scratch with a default animation. I add a parameter and rename it to start time. Its default value will be time function, which will be evaluated at the time this agent is being created. Basically, start time works as a timestamp that records the arrival time of each car into the model. Now I create an initially empty population of agents that are from the car type that we've just created. I click on each car source, and under the Advanced section, I will assign the added cars to the custom population that we've created in the last step. Just remember to change the new car type in all the car sources to car. To assign the added cars to the custom population, you can either use the element chooser or the drop-down menu. Next is to add a histogram data from Analysis palette. Double-click on the cars population to add a piece of code to its onDestroy field. We point to the histogram in the main and add the difference between current time and the time this car arrived at the model. Basically, we record the duration of time this car will spend in the model. Let's add a histogram and assign the time in model histogram to it. I want this graph to show the mean as well. Okay, if I run the model and let it run for a reasonable time, we will be able to see the mean duration time that the car spent in this model. This average value is a good performance measure indicator of traffic signal controls. Before we start building the optimization experiment, let's change the model stop time. I want this model to run for 10 minutes, which is enough to go through several cycles. As you can see, the average time in the model is around 55 seconds with the current setup of traffic lights. Let's see if we can reduce this number by optimizing the traffic lights phases. I want to parameterize duration of each phase, therefore I need 4 parameters with a default value of 30 seconds. Now I go back to each traffic light and change the duration of each phase with the parameters. To create a new optimization experiment, I need to right-click on the model, New Experiment, and select the optimization experiment. As you see, all parameters in the main are now in the optimization experiment. Our objective is to minimize the mean value of the time all cars spend in the model. Route here points to main. Time in model is the histogram object inside main. I will change the type of all 4 parameters to discrete. Their values could be between 10 to 35 seconds with steps of 5. Now I create a default UI and then run the optimization experiment. Here you can see that AnyLogic automatically detects the number of available cores and runs several iterations in parallel on different processor cores. The chart visually illustrates the optimization process. The x-axis represents simulations, and the y-axis represents current objective, best feasible objective, and best infeasible objective found for each simulation. Okay, now I can copy the best feasible values and paste them to the original simulation experiment. We can see that the mean value is decreased to 46 seconds after optimizing the traffic lights. At this step, I want to add a parking lot to the model. Parking lot is a space markup element in road traffic library. I changed the number of parking spaces to 10. Now I need to add a select output, a car move to, and a delay block to this part of the flowchart. Some of the cars that are starting at left segment of the upper road will go to this parking lot. Their duration of stay in the parking lot is coming from a triangular distribution. You can choose from a large set of probability distributions by clicking on the Choose Probability Distribution icon. The delay also has a maximum capacity. As you can see, 50% of cars will try to park in the parking lot. Let's run the model and observe the parking lot. I received the car failed to reserve a parking space in parking lot error. Similar to what we did before, I will use the out way not found port to tell the cars that cannot park to go straight. Let's run the model again and observe the parking lot. It looks like everything is working as expected. Okay, let's add a bus route. I'm adding 3 bus stops to the network. Here, I want to create the flowchart associated with the buses starting with a car source. Next is to build a custom agent type for buses. I choose this icon. I'm adding a parameter and name it stop counter. This parameter is of type integer and counts the number of bus stops each bus has passed by. I want to build a custom object for bus routes. I bring an agent from the agent palette. I select a single agent, choose I want to create a new agent type. Agent type name is bus route and click finish. I add a picture from pictures palette for the icon representing this custom object. We need two ports that we can bring from the agent palette. Click on the shape and check the icon checkbox to make it an icon. Now I can build the flowchart that each bus will pass through whenever they enter this custom object. We need a car move to, a delay, and a select output. I connect the two ports we've added to the associated ports in the flowchart. Make sure all the connectors are connected correctly. Okay, let's go back to the main and complete the flowchart. Whenever a bus is injected to the model, it goes to the bus route custom object. Buses will be injected into the model with a rate of 1 per minute. They start at the right segment of the bottom road. Length of the buses is 8 meters. Their initial and preferred speed are 40 kilometers per hour. If needed, you can change the unit of length or speed from the drop-down menus on the right. I also unchecked the random lane checkbox and asked the bus to start at the lane with the index of 0, which is the furthest right lane. After going through all the bus stops, each bus will go to the right segment of the upper road and eventually leaves the model. Okay, now I want my custom object to be capable of selecting the bus stops. To do so, I need to add a parameter to bus route. The parameter is an array of bus stops. I change its label to bus stops and its control type should be one-dimensional array. Now if I go back and click on the bus route object, it lets me pick the bus stops and put them in the array. I choose the bus stops in the correct order. Okay, let's go back to the custom object and set the properties of each block. The agents that are passing through this custom object are of type bus and they are moving to bus stops. Each bus will pick its next stop from the bus stops array, starting from index 0. Then the bus increments its stop counter to know the index of the next bus stop. This select output should work similar to a while loop. As long as the bus has not passed by all the bus stops, it will be sent back to the car move to block. We need a condition here. This condition says that if the bus's stop counter is equal to the total number of bus stops in the bus stops array, then the bus has passed by all the stops and it should exit the bus route object. Finally, I adjust the values of triangular distribution in the delay. Delay has maximum capacity. Now it's time to run the model, but first I want to set the stop time of the model to never so that I can run it as long as I want. You can see that the buses are moving in the furthest right lane and stop at each bus stop as we expected. Let's add a road network descriptor. You can use it to get access to all the vehicles located in one road network. I want to enable traffic density map, which is a semi-transparent coloring of roads depending on the average speed of a car on each section of the road. I set the road section length to 20 meters. These sections are used in density maps and average speed reporting. Let's run the model and see the density map. Traffic density map is shown in both 2D and 3D animation. Now it's time to add some pedestrian to the mix. First, I draw a wall around the pedestrian movement area. The wall space markup is on top of pedestrian library palette. I draw two target lines and a rectangular area to define the pedestrian movement. We need a ped area descriptor. This block allows to define rules on pedestrians being inside the rectangular area. Check the Enable Access Control checkbox. We need a stop line here. I'm going to add a traffic light block and assign it to this stop line. The traffic light will specify the traffic behavior at this stop line. I'm modifying the phases of this traffic light. Let's modify the flowchart and add the pedestrians. I start with a split block that lets us create several pedestrians for each incoming car. We need a ped enter after the split to assign location to pedestrians and inject them into the model. I'm adding 3 ped go-to blocks here and a ped sync at the end. Before setting the attributes of these blocks, we need to add a custom pedestrian type. I keep the default animation and add 2 parameters to record the pedestrian's initial location. Now on the split block, the new agent type should be the custom pedestrian. Number of copies or the passengers of the cars is coming from a discrete uniform distribution. On exit copy field, we assign the location of cars to the pedestrians. Agent is the pedestrian and original is the car. We get the X and Y of the car and assign it to the pedestrian. For the y-axis of the pedestrian, I add a 5-pixel offset. Pedestrians that are injected by ped enter should appear at a point. X and Y values of that point is equal to the values of x and y parameters inside each pedestrian. Now I'm setting the movement of pedestrians by the three ped go-to blocks. First, they go to the bottom target line, then the rectangular area, and finally the target line on top. Okay, now we are ready to run the model and see the pedestrian movement. I turn off the density map first. You can see that the cars are parking and passengers getting out of the cars. They move toward the target line. The problem is passengers don't pay attention to the traffic light and cross the road whenever they reach the target line, even when the light is green for the cars. Okay, we can fix this by going to the traffic lights, and on phase change field, I only open ped area descriptor during the red light. Current phase index equals 2 means when the traffic light is in red phase. Whenever the phase index is not equal to 2, the expression will be false, and therefore ped area descriptor will be closed, which will prevent pedestrians from crossing the road. As you can see, the pedestrians only start crossing the road when the traffic light is red. However, if pedestrians are in the middle of road and traffic light turns green, cars will ignore the pedestrians and pass through them. To fix this, we can add a second stop line and put it after the stop line assigned to the traffic light. Now I can go to the onEnter field of ped area descriptor and set the signal of the stop line to red. This means that whenever a pedestrian moves into the rectangular area, the stop line will be red, stopping cars from passing. We also need to change the light to green whenever the rectangular area is empty. I do this by adding this code in the onExit field. Okay, let's run the model and see the results. At this moment, the traffic light is red and pedestrians start crossing the road. Now the traffic light is green, but cars are not moving because some pedestrians are in the rectangular area and therefore the second stop line is red. Okay, looks like everything works fine. Okay, so I hope you enjoyed the model building process. I'm going to share my screen with you and show you some points and nuances in the model that in more detail. So one of the main thing that we did in this model was adding pedestrian to the traffic, and we wanted the pedestrian to pass through this road and cross this road. And as you saw, we had two stop lines here. The first stop line is connected to this traffic light and is actually modeling the real traffic light that we have in physical traffic light that we have in the model. The second one is some sort of virtual traffic light that we added to keep the cars passing through this intersection whenever somebody is still crossing the intersection. And what we did was to add a small piece of code in the ped area descriptor to tell the cars that whenever somebody enters this rectangular area, this stop line should be red, stopping cars from passing over. And whenever somebody goes out of this rectangular area, we check that if anybody is inside the rectangular area, and if the answer is yes, if the answer is no and nobody is there, then we turn the second and the virtual stop line to green, so the cars can pass the street. The other part that we talked about and you saw is this out port. Whenever the cars were unable to um, turn on the right moment, so we use this thing to tell them that when you can't turn, just go ahead straight. What I want to show you how you can resolve this issue without using this out port. Let me open a second model that I have here to demonstrate that. So here we have this intersection. Let me run this model so you can see the model during the runtime, and then I will talk about how it works. So here we have this intersection, and we have cars that are coming into this intersection. Most of them will try to pass through and go straight. Some of them will turn right, and some of them will turn left. By this type of construct, by this type of flowchart, we can put the cars, a portion of a car, on a specific lane. So as you can see here, we have 4 lanes, 0, 1, 2, 3, and I will generate some cars here, but I use the source from the process modeling library. So when you're generating cars from this type of source, which is a generic process modeling library source, we haven't put the cars on the road network yet. We are actually going to put them on the network with this car enter blocks. And the way and then we have these select output 5 that lets us to separate them into different groups. And here on enter car, I will put them on a specific place. For example, for the cars that are passing through and they want to go straight, I assign a random lane to them. But for the cars that are turning right, I say that they should be either in the 0 or 1 lane. So they will be on the right side of the road. So, and therefore they will have enough time to turn left without resulting in any error. The same thing we did for the cars that are turning right, and we put them into either lane 2 or 3. So so let me run this, and also I want to show you something else in this model. One of the other questions that you might have is, how can I make these cars a little bit different? How can I make them having different speeds and so on, or even different attributes, or injecting different types of car? As you can see, as you saw in the model, we injected buses into the model, and same as that approach, you can add as many car sources as you want into any direction and inject different types of cars. As you can see here, this truck is moving slower than these cars, and some of these cars have a higher speed than the others. The way that you do it is, when you have a car source and you inject the cars by a car source, or they enter into the model by car enter, you can click on that, and you have access to the initial speed and preferred speed of the car. So in this case, for example, for the cars that are going straight, I pick their preferred speed from a uniform discrete distribution, which means that we have a variety of speeds for the cars that are passing through. So with this type of construct, you can add variety in the cars that you have, and you also can put them in specific lanes. One other question is about how I can add 3D views into our models. In the model that we just built, we used the car, we added customized car agent type into the model, and that car has a 3D icon associated with it. The only thing that you need to do is to go to the presentation palette and add a 3D window. You just put it there and resize it to match the size of your screen, or whatever dimension that you want to. You add this, and AnyLogic automatically generates a 3D view for you. And if you want to add some different objects, more objects 3D into your model, you always can go to the 3D objects view and add trees and other objects into the model. So for example, I added tree here. So now if I run the model, you can see that I have that 3D view as well. So I can go here and I can look at the same model in a 3D view without doing anything. So everything will be generated for you. And this is the tree that I've just added here. So the other question is how we can get more resources, how I can get more resources about the road traffic library. We have a very extensive help section related to the road traffic. You can actually look at the tutorials as well. We have this tutorial intersection here that shows you how you can draw roads that are curved as well, which is pretty simple to do. And also under the library references guide, we have a specific section just for the road traffic library, and all the blocks that are in the library are here, so you can go and read all the fields, some generic information about how to use them, all the parameters and all the fields that are related to them, also all the functions that you can use by code. This is another resource, so this is very useful, and also you can look at the drawing parts of it. It shows you how to draw draw different roads and intersection. It shows you some techniques in how to draw curved roads as well. The last resource that I wanted to show you is the AnyLogic example models. If you go to the example models, we have this road traffic section under these examples, and we have currently 4 models. We updating these models and we add more, and you can open each of these models, and you have the source code and everything is inside this model. As you can see, in this specific model we have a more complex layout and network, and these could be built pretty easily with AnyLogic road traffic library. For the sake of time, we use the simpler geometry for the road network that we did in this webinar, but you can do as complex as you want. Okay, so let me just run this model, and you can run these models and look at the logic and everything that is related to these models. So it has a 3D and 2D object, 2D view, and statistics and logic of the model for your review. Okay, so our time is up today. Thank you very much for attending this webinar. Don't forget, we would like to have your feedback, and there is a link in the notes pod on the right side of your screen. You will receive a follow-up email. The follow-up email has a link to the survey and also the recording of the webinar, the Q&A section as well, and also you receive the source code. Thanks again, and have a great rest of your week. Thank you.